On the screen, a complete titration setup is shown with the burette clamped above a conical flask on a white tile, and the aim is to find the reacting volume of a strong acid and a strong alkali using sulfuric acid and sodium hydroxide. We zoom to the particles to show neutralization, where hydrogen ions from the acid meet hydroxide ions from the alkali to make water, while the balanced equation H2SO4 plus 2NaOH makes Na2SO4 and 2H2O appears to explain what reacts and what forms. A pipette measures exactly 25.0 cubic centimeters of sodium hydroxide into the conical flask because a fixed known volume gives accurate stoichiometry, and the white tile helps us see the color change clearly. A few drops of indicator are added, and a color key for phenolphthalein and methyl orange is shown because for a strong acid and strong base, we need a sharp change near pH 7, so the endpoint is unambiguous. The burette is rinsed with the acid, then filled, and any air bubble at the tip is removed, and the initial reading is taken at eye level to the nearest 0.05 cubic centimeters because rinsing prevents dilution errors, and eye level reading avoids parallax. A quick rough titration is run by letting acid flow into the swirling flask until the first just visible color change, so we know roughly where the endpoint happens and where to slow down. Accurate titrations are then repeated, adding the acid fast at first and then drop-wise near the endpoint until two or more concordant titers within 0.10 cubic centimeters are obtained, which increases reliability. The reacting volume of the acid is calculated as the mean of the concordant titers using final minus initial burette readings, and this value is highlighted in a results table so we can see how each run contributes. If the titer is far from the green window of 20 to 35 cubic centimeters, the starting concentrations or volumes are adjusted so the endpoint falls in that range, which gives the best precision and easy burette control. The concentration is then found using moles equals concentration times volume in liters, together with the stoichiometric ratio of 2 moles of sodium hydroxide per mole of sulfuric acid, which links the moles in the flask to the moles delivered from the burette. A worked example shows that when 25.0 cubic centimeters of sodium hydroxide at known concentration are titrated, the mean volume of sulfuric acid gives the moles of base, which are halved to get the moles of acid, and then divided by the measured volume in liters to give the acid concentration to suitable significant figures. Safety and quality icons remind us to wear eye protection, rinse glassware with the solutions, read the meniscus at eye level, swirl on a white tile, dispose of chemicals properly, and report the mean titer with uncertainty while explaining errors such as parallax, faint endpoints, and drops left on the tip.